Hi. We have two more patients from James Condon. I showed these at the end of the last video, repairing the carburetor float pin posts that was broken off. We fixed it in the last carburetor, which was a Nikki. These are two Mikunis for different engines, but similarly hard to find original carburetors and reasons not to use the aftermarkets. After the last video, I got a number of questions about why not weld it or epoxy the part back on or do a number of other remedies that would work for somebody who was in a pinch and needed to fix their own machine. As we'll see on these, the broken part of the post is much higher up, smaller, and in fact missing from both of these. So any repair attempt that would have tried to reattach that part won't apply here. Also, since these are going to end up in somebody else's machines down the road, we're hoping for repairs that can withstand the test of time and last the life of the machine they're attached to. So in the last video, that prototype repair was lining up and aiming for what these need, which is making a new part to thread on and replace it. So let's get these open and take a look at what damage lies inside. These have similar damage to the one I fixed in a recent video. James tested out the one that I just fixed and mailed back to him. He said it seemed to line up right, regulated the fuel level correctly, no issues seen. So we're going to proceed with these. I think it's going to be very similar. I'm not going to mill as far down because these raised mounting posts come very close to this seal, and I don't want to interfere with that at all. So we're going to probably try to do smaller brass or aluminum standoff if we can, but I want enough material around it to support the pin and not cause any issues. So we'll come down a little lower. We'll try and do both of these at the same time. Try and maybe mill them down the same amount, make an identical repair to both. So we'll get these ready for going into the mill. To hold these upside down in the mill well enough, I need to take as much of this off as I can. So I did this last time, I didn't show it. I'm hoping to remove the choke and throttle plates. Hopefully they come out easily. This one feels pretty stuck though, so I might have to get some solvent in here and get this one loose so I can turn it and get the screws out. This one feels good. Then I'll have to take the old gasket material off of here so that this will sit properly in the mill vise. With the gasket material here, I won't be able to clamp it well. It might move around, and it might also put undue pressure on one part of this casting that I'd rather avoid. So we'll get these cleaned up and ready for surgery. Yeah, this throttle plate is pretty well stuck, and it's going to have to come out. See if a little bit of solvent penetrates down in there. There we go. All right. I'll get a razor blade and carefully scrape this gasket material off, and we'll head to the mill. All right, we're set up in the mill. I thought I was going to start with the one that was more broken, but they're broken in pretty much the same exact way. So I think what we'll do is come down until we mill off a spot that's basically level with that bore that comes up for the pin or the needle. So I think I'm lined up to come straight down on top of this. We'll clean it up, and then we'll do what we did last time and figure out where exactly we want to place a hole for a stud to go in there, keeping in mind that on this one we can't interfere with where the bowl comes up to meet this seal here. That's right on. I think to locate the hole and the stud for the repair, we'd ideally be on center with where the pin goes. This carb didn't have a pin with it, and the one from the other carb is too loose in here. So I have my full set of drill bits here. We're going to go through and find one that acts as a good pin to indicate off of. Let's see if we can get a little tighter than that. All right, so number 43 fits through pretty well, but the number 42 doesn't fit. So this number 43 drill is 89 thousandths. The next one larger is 93 and doesn't fit. Without making something, that's the closest fit I have. So we'll center find off of this right up against here. I'll see maybe if I can hold it straight to get it a little more accurate, but this will have to do. All right. So I just bias this down with my thumb, letting the this side rest in the bottom and the far side hit the top, and that centers up so it doesn't move forward and back at all. So that should give us a really good indication of where the center line of this is. So now we'll center up over here. We'll just visually center up right, left on this. It doesn't matter nearly as much as being on center with that this way. So we'll visually center up on this, and then we'll drill and tap for 440 just like last time. As it happens, a 43 drill that we just tested with for the lining up on that pinhole is the tap drill for our 440 screw. It's about 5/16 deep. So that was the starter tap. This is the bottoming tap. I don't think we need it, but it can't hurt. And I'd rather not have to try and fish a stud out of there if it doesn't screw in as far as we want later on. This hole is drilled and tapped, bottomed out, 5/16 deep. We'll get the other one to the same stage. All right, ready to do the same thing here. To level these off across the vise, tilting this way, I'm actually just using a digital angle gauge, zeroing it out against the vise, and then resting it across the groove for the bowl here. It's not at all critical. It only affects exactly how perpendicular our stud replacement on here is going to be, but that doesn't actually impact the viability of the repair in any meaningful way. You can see we just touched the raised boss of the needle, so we're there. It's about as loose as the other one was, so I'll keep pressing down on this so we'll edge find it. Unsurprisingly, the pin center is the same distance off the jaw. Working with these smaller taps reminds me of college. I had a roommate who asked me to borrow a tap for something. It was on the smaller end. It might have been as large as a number 10. Maybe it was number 6. What I remember is that it was a helical spiral tap, and it was one of the only ones I had. And I specifically said to him, hey, I don't recommend you hold this all in your hand. I always use a tap center with smaller taps. Back then I didn't really know to. I said, at least put the workpiece in a vise. And he said, oh, I know, I'll be careful. And instead, he ended up just tapping it over the kitchen sink. And I heard it from the other room. Tink! Ah, shit! I don't think he ever ended up buying me a new tap. I think I got a sorry, and that was about it. But I've learned that lesson probably only a week or two before he did. Both carbs are up to the same stage now, so I will go find something to make these replacement studs out of. This is quite a bit less meat than last time. This is less than 1/4 inch. Maybe 3/16 for this one. So we'll make two 3/16 studs with a 440 hole tapped in the bottom and go from there. Found this piece of aluminum stock. It's 1/4 inch. We're going to shoot for 3/16. And the length we're going for, so the replacement height of the post, is about 0.3 inches, so we'll probably shoot for 5/16 over here. That's from the top of the remaining good post to the milled surface on both carburetors. They're within 0.02 of each other, and it's right around 0.3 inches. So we're shooting for 3/16, 0.1875. We started out at 1/4. The first pass took us to 240. We're at 0.2 now. So we'll split our finished passes into 6 thou and then whatever else it comes down to. There we are. We'll drill and tap that for 440 right here, and then part it off. Ideally, we would only drill 1/8 of an inch or so, but there's just not enough way to get enough good threads there to hold this together. The tap really needs to go in at least 5 or 6 threads. So realistically, this stud or this standoff we're making is going to end up going all the way out the top of the new post. And we'll just have to hope that when we cross drill this, that we're on the right center to not have the bit wander either way and affect the pin fitment too badly. Well, that's gone to the chip tray. Let's do it again. Alright, that was one. Alright, that's two. If I do this again, I'll have to mill these down further. This process of dialing it into the exact right number of threads is tedious and unnecessary if I had just milled it down further. But I really would like shooting for the minimal repair. Really like at least 3 full threads here. Barely gonna get that. Now that we got those on there, we have to do one more step a little differently than last time. Last time, we located the stud on a larger flat spot based on where the float ends up. Here, we located it centered on where we milled the spot down because we had a smaller landing spot and didn't want to risk coming out into where the seal is and where the bowl would interfere with. As a result, we didn't ensure clearance for the float to fit in, and we probably have about 15 or 20 thousandths of interference. So we're going to put this back in the mill vertically, take a pass in front of this, and put in some clearance, kind of like the flat side on this standoff here. We're going to add a step on here so the float fits in. I'm not super thrilled about milling against the side of this with how few threads we have in here. Like I said earlier, in an ideal world, we would have maybe milled down further instead of going for the absolute minimum repair here. But worst case is it rips the aluminum off the stud because there's relatively few threads in here. It's in the casting very well. So if it does fail, it's not going to damage the carburetor. It should just rip the aluminum off the stud, in which case we can reevaluate whether to mill down further and start over or something else. But we'll get this up in the mill. We'll peck away at this to make the relief we need, and then we'll take it from there. So we'll come down right on top of the boss here. Just off of it. No reason to cut it if we don't have to. And then we will come over, touch the peg, move back and forth, clearance the inside of that until the float fits. So I just touched it. I'll set that as my 0. We'll do another 10 thou. More. I think we've got it. I'd rather not take any more since we're right up against, any further and the threads will start peeking through from the middle of our barrel nut we put on the top. It can always be clearance. If it's not going to be this exact float, it can always be hit with a file a little bit to clean up one side or the other. Maybe I'll take a very light skim pass on this side, but again, going with the minimal repair, I'd rather leave this alone and let James potentially have to clean this up with sandpaper or a file, or take a little bit off the inside of the float to get this to fit exactly right, just in case this float doesn't go on this carburetor or there's some other variants. I think we're going to call that good rather than push it any further unnecessarily. So now we'll take this out, blow it off, and do the other one. I dare say I like that better than the one in the last video with the brass cylindrical standoff. That actually looks closer to factory. We could have milled the back side of this if we really wanted to make it look like the other one, but this minimal repair approach kept that step where it originally was. And then we got the flat that looks just like the other side. That's pretty cool. So they both came out great. Gonna reassemble these, get the choke and the throttle plates back in. I've got the parts separate just in case there's any wear patterns that make this one want to go with the carb it goes with. So we'll get these back together and kind of debrief and see how we did. Things together and ready to go. Blew everything out, put it together. I didn't relocate these screws in case James wants to take them apart and clean inside here any differently before these ever get reused. I put this one together with the float, blew through this. Everything seals up real nice. You can see that's on the spring a little bit off the pin, off the needle in there. And I think we're all set to go. So this is yet another proof of the concept, +1 of this repair. This particular, both of these, the tops were broken off. So replacing the top of the post was the only option. There was no piece to put back on. The piece that was broken off, as we saw in the beginning, was just part of the circle, part of the outside of the hole around the pin boss itself. So no choice on these but to make one, which is why in the last video we made one as well, because that was building up to this repair. So we'll get these in the mail, put them on James's shelf, and hopefully see them show up in a future repair to get a machine going that otherwise would be headed to the scrap pile. Thanks for watching. You'll see me next time.